Hello students, in this today's video lecture of engineering graphics, we'll see how to construct an ellipse. In the previous lecture we have seen how different conic sections obtain by cutting a regular cone in different positions with different inclinations. Okay, we have seen way parabola will obtain or a hyperbola will obtain, ellipse will obtain or a circle will obtain. Okay, and we'll try to construct them with the help of eccentric method. Okay, for example, today's topic is all about constructing an ellipse by eccentric method, what you call. Fine. Now this eccentric method is represented with small e. I'll give you a simple idea before moving on to actual sketch. For example, we know the shape of an ellipse. For example, this is a simple shape of an ellipse. Let us consider this as the shape of an ellipse. Now wherever, let us think that this is the starting point of ellipse, this is the ending point of ellipse. I'm starting here. Okay, it is moving this way and this way, it is ending at this particular point. The point where it is starting, we call it as vertex point 1, ending point as vertex point 2. Okay, I'm trying to make you understand the basic terminology related to this particular conic sections. Unless you know the terminology, you don't understand the question properly. Fine, V1, V2. These are the main important points related to this particular. Now the line connecting these two, we call it as axis line, and there will be a line perpendicular to this particular axis line, and we call this line as directrix. Okay. Now in general practice, what we try to do is we'll try to name this directrix as AB or whatever the alphabet you would like to give, you can give it. Similarly for the axis CD, we can consider it. And other than these vertices V1 and V2, there is one more point called focus F1, and whatever the distance between V1 and F1 will maintain, same distance going to be between V2 and F2. We'll see what is F1 and F2 in the actual practice of an ellipse by eccentric method. Fine. Now this is the basic terminology. V1, V2 called as V1, V2 vertices. Okay, and F1, F2 as focus point. Okay, let us consider this AB as directrix and CD as axis. This will never change. We are now focus one more thing. We are discussing about eccentric method. In this eccentric method, we are going to construct an ellipse, parabola and hyperbola. In all the three, this particular terminology will not change. That will remain same. The vertical one called as directrix, horizontal one called as axis line, where you will have two focus points, two vertex points. Now how to arrive to those two focus points and vertex point, we'll see in the actual practice of an ellipse. Okay. And one more thing to be noted here is there won't be any finite distance for this AB and CD. There won't be any finite. It is an infinite distance. We can take it conventionally, whatever is required. Now we'll try to focus on how to get this particular solution. And one more thing to be noted here is we need to talk about E also, eccentricity E. What is the formula for eccentricity E? That is also important. Whenever we talk about ellipse, the value of E less than 1 means in the question he may give you as ratio as 2/3. The ratio may be 2/3. In some cases 3/4 also. Okay, because it is less than 1. Similarly, if it is we need to construct a parabola, then in an eccentric method, then value of E is equal to 1. Okay, which we call it as parabola. Similarly, E greater than 1 for hyperbola. This is how we'll do. Now he'll mention in the question, draw an ellipse by eccentric method, or else he'll directly give you with a ratio of 2/3. If the ratio is 2/3, it is none other than this particular ellipse by eccentric method only. Followed by, he'll give you a distance of focus also. Distance of focus will be given to you in the question. This particular ratio will be given to you, followed by distance of focus from directrix, maybe 50 mm or 42 mm. Any number will be given to you. By considering these two values, you need to construct an ellipse by eccentric way. Fine. Now this vertex point, what we were discussing, vertex point is called as point of intersection because it is starting at that particular point. You can call this vertex as point of intersection. We need to know this terminology. This is more important. And focus as fixed point on axis, whereas directrix is a fixed straight line. vertex is a point of intersection, focus fixed point at an axis. Okay, point of intersection means on this particular axis this is the point of intersection 1, point of intersection 2. He may give you a distance in the question. Sometimes he may give you a distance talking about point of intersection. In that case you need to understand that he is talking about a vertex point. In a similar fashion, fixed point on axis line, nothing but a focus. In terms of question, he may give you directly like the distance of a fixed point on axis is 50 mm, nothing but a focus. He is talking about a focus. Similarly, fixed straight line is nothing but a vertical line, directrix. Okay, now here what is ellipse is nothing but a point. If you consider a point P, okay, now if you consider this as point P, this particular point P is traveling all around. Okay, similarly this way also it is trying to create number of points at every instance. If you join all the points, you are going to get the final product, final ellipse. Maybe if I consider this as P, this is going to be P1, P2, P3, P4. Similarly you will get it. We can actually find what exactly the where exactly you are going to get the V2 also. This can also be calculated. That we'll see when we'll go with some actual practice. Fine. Now we'll try to draw this particular ellipse by considering few specifications. Like the question is going to be some randomly we'll take few numbers. Okay, the question is draw an ellipse by taking 2/3 as the ratio with a focus distance of 50 mm. He may give you focus distance of 50 mm or 40 mm. Okay, or else he may give you fixed point on axis maintaining a distance of 50 mm, nothing but a focus again. Try to read out this terminology, remember this terminology so that you'll understand the question properly. Okay, now before moving on to this, what is E? E is nothing but eccentricity. What is eccentricity? It is a distance. Now what is the ratio? 2/3 ratio is distance of moving point from focus. This is the distance of moving point from focus divided by distance of moving point from directrix. Distance of moving point from directrix. For example, if this is your point, let us consider P1 as the point, P1 as the point. E is equal to distance of moving point from focus. This is the distance. Here you could see. Similarly, distance of moving point from the directrix is the distance. Fine, that is nothing but the eccentricity. If you give some numbers here, like for example FV, this distance you consider it as FV by VC. If I consider this as FV by VC is the ratio. What is that? Initially I have given some alphabetical order. Like if I consider this as 1, this as V1, this as C, then the formula for this distance of moving point from focus, distance of moving point from focus. Now this distance is equivalent to this distance. In actual practice you could see that. Then we can call this as FV by, you can write in this way, FB by VC is equal to E. Now which is a constant that will not change. Let us move on to actual what you call drawing an ellipse by eccentric method. Now I'll consider this directrix. I'll draw a bit bigger. This is going to be the directrix. Then from the middle, now this distance is not defined actually. Okay, let us call this as AB, and from here axis line, some infinite distance. Let us name this also. Fine, let us name this as, then now what we try to do is, now this is directrix, this is axis line. Now distance given for focus is 50 mm. So from this directrix point I need to make a mark of 50 on the axis line. Now this is focus F1. Now this ratio is given already, 2/3 ratio, nothing but eccentricity method to develop an ellipse. Now that is equal to, this equation is equal to 2/3. If you add up above and below, if you add up these two, overall it is going to be 2 plus 3 is going to be 5. Now we need to divide this CF1 into 5 parts. What is that? CF1 we need to divide into 5 parts. This particular whole thing. Now the complete distance is, the complete distance we have considered here is 50 mm, 50, complete distance, okay, with respect to this particular line, focus point 50 mm is given. I made a mark of 50 mm. Now whatever we are constructing, we need to construct with 2H pencil only. We need to use 2H pencil, okay, 2H pencil, which is a light pencil that we need to use for complete construction. Later the required projection, required sketch need to be darkened with using HB pencil, okay, which is a light pencil. Now after marking this, I'll try to divide this into 5 divisions, because now I'm adding up 2 plus 3, I'm getting 5 as the part. If I'll divide this into 5 parts, now here each division going to be 10 mm, maybe 2, 1, 2, 3, 4, 5, 4 divisions. Okay. Let us name this first division, second division, third division, fourth and fifth going to be the focus. 5, 1, 2, 3, 4, 5. Fine. Now here distance of moving point from the focus, moving point is where from the focus, here is the moving point which is V1. As I said in the beginning, V1 is the starting point, nothing but the moving point. Now it is at what distance? It is at 2 parts from the focus. Why from 2? Why 2 parts? Because 2 by 3 is the ratio. If 2 by 3 is the ratio, 2 parts from the focus. Okay. From here, first part, this is going to second part. At this point, you are going to get V1, vertex 1. Got it? Now 2 parts from the focus. Distance of moving point from focus. This is the moving point V1. Now it is placed at a distance of 2 parts from the focus, 2 parts V1. And 3 parts from the, have a look at this, distance of moving point, same moving point from directrix. This is about that point, which is 3 parts, 1, 2, 3 divisions. So number 3 going to be V1, where ellipse going to start or move this particular point. Now how this ellipse will start or move from that particular point is more important. Now here what I try to do is, I'll try to draw a vertical at V1. I'll try to draw a simple vertical of infinite distance, some distance. Okay. Then I'll measure the distance from 3 to 5 or else 3 to F1. Both are same. 3 to 5 or 3 to F1. 3 to 5 or, sorry, I'll put it this way, 3 to 5 or 3 to F1 distance I'll try to measure. If I measure this, it is going to be 20, because overall it is going to be, it is 40, overall it is 50 given. So this distance is going to be 20. If this is 20 mm, if this distance is 20 mm, now I'll try to measure this distance with the help of compass. Taking V1 as center, I'll try to trace an arc, okay, which will cut the vertical. Okay, taking V1 as center, whole thing 20 as the radius. If I draw an arc, it will come and cut the vertical somewhere. Means this distance is equivalent to this distance. That is more important. Or else you can measure directly with the help of scale. You can make a mark with the help of compass. Okay. I'll measure this 3 to 5 distance, which is 20. V1 as center, just cut it. Now draw a line in such a way it should pass through this particular point. Let us name this point as E, this particular intersection as E. Okay. Now I'll draw a line in such a way that it should pass through CE, some infinite distance line. It should pass through CE and up to some infinite distance with the help of scale. Everything has to be done by using a drafter only. Okay, just to make you understand, to speed up my work, I am using freehand, but you have to work by using drafter. Fine. I have taken some extension up to some infinite distance. Afterwards, now this is V1. To get this V2, the ending point of an ellipse, where it is going to end, the major distance, ellipse will have major axis and minor axis. Now to fix this major axis can be fixed initially only. You can fix it. What is a way or method to fix that particular major can be fixed in this way. For example, we are already having this particular focus point F1. Align your drafter 45 degrees, your drafter to 45 degrees, and with respect to this particular point F1, draw a line. Align your drafter to 45 degrees and taking this as the reference, draw a line until it go and meet the inclination already we have drawn, which is passing to C. I'll align my drafter and try to draw a line passing something like this, 45 degrees line, inclination to 45, it should pass through something like this. It will go and meet the inclination somewhere. From there, try to drop this particular line onto the axis. Now this point, wherever you drop that point as, we consider that as V2. And from here 2 parts going to be F2. This is V2, F2. Fine. So means it is going to start at this point, going to end up at this particular point. Now after this, now this angle here, the angle need to be maintained is 45 degrees. Okay. Now try to divide the portion, this portion from F1 to V2 into number of divisions, and the divisions could be equal or unequal. It all depends. Right? It is not compulsory that you have to make equal divisions, but better to go with equal divisions. Okay. Already we had two divisions, 3, 4, 5. I'll try to make one more 10 mm, 20, some 30, 40 is there, some more divisions. We made few divisions. Let us consider this as, I'll try to draw wherever I made markings of divisions. I'll try to draw an extension line above and below. Now for example, here I'll try to extend this 0.4 up to this particular inclination until it go and meet the inclination. Just a parallel line from that particular intersection, just a parallel line with the help of drafter. If you align your drafter to the directrix, okay, above and below, similarly above and below with 2H pencil, which is a construction pencil. Okay. Just to construct we'll use it, fine, at some infinite distance, or else you can draw the same line to the other side also, and try to develop the same process, same procedure, you'll get it, fine. After doing this, let us name this as, if I consider the first division as 1, let us consider first division as this first division. Now don't consider these 5 points now. Now we are at this particular point V1. After that V1 it is going to be 1, 2, this is 3, 4, 5, 6, 7, and this last one is 8. Okay. If this is 1, this becomes 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, 6 prime, 7 prime and 8 prime. Okay. 1 prime, 2 prime. Okay. Now once you construct this whole process, simple thing is focus acts as center, always focus acts as center, and radiuses will keep on change, radius will change. What is the radius going to be? 1 prime, 2 prime, so on, 8 prime. Okay. Center will remain same, means for example, if I consider 1 prime as radius, 1 prime as radius, F as center, okay, F as center, I need to cut the same line above and below. Similarly, F as center, 2 prime as radius, F as center remaining same, so I need to cut above and below. Similarly, 3 dash as radius, F as center, I need to cut here above and below. 4 dash, 4 prime as radius, center, F as center, cut it, something like this. Similarly, 5 prime, 6 prime, 7 prime. So your curve starts coming down slowly, something like this. Last point, whenever you take 8 primes, F as center, it will come and cut the axis line somewhere here. Now these are the intersections you got. These intersections need to be constructed, means you need to join with the help of a free curve, with the help of hand. Okay. You need to join them with 2H pencils slowly, something like this. As this is our ultimate aim, you need to darken this particular thing. Once, okay, this is the ultimate ellipse what we got, that is the only thing need to be highlighted. So we need to darken with 2H pencil. Let us consider this as 2H pencil, darken it. This is the ellipse, ultimate ellipse what we got. Okay. Now divisions could be equal, unequal. This is how we will construct an ellipse. Okay. So if you know the terminology, all other things becomes very simple. Now once this is done, you need to name it. This is P, this is going to be P1, P2, P3, P4 point, P5 point, P6 point, P7 point, P8 point. Similarly, if this is P1, this is going to be P1 prime, P2 prime, P3 prime, P4 prime, similarly P5 prime, P6, P7. This is how we will construct an ellipse. In a similar fashion, we can construct a parabola, hyperbola also. The procedure is similar. Procedure is completely similar. Only thing is, in case of parabola, here the curve will not travel down. It will keep on move this way. This will move this way. In case of hyperbola, the same curve will travel with respect to this particular inclination in a broader way, something like this, the wider way. Okay. These two curves will not meet each other at any point. Okay. For the same ellipse, he may ask you to construct tangent and normal also in some cases. He may ask you to construct tangent and normal. Okay. The question is something like this. For example, he may ask you draw tangent and normal for the same sketch. Continuation is tangent and normal at a distance of some from the directrix. Maybe this is the question, 80 mm from the directrix. Now at this point what you need to do is, from the directrix you need to fix the point 80. From this directrix, below the axis line or above the axis line, that is your wish, you have to fix this particular distance of 80. Already we are maintaining some 50, 30 more if you will take, you will get a point. For example, at this particular point, maybe from 50, here is your point. This cross mark is the point. Okay, now that point need to be joined, or try to join this point with the focus. Here is the focus point. Try to join this point with the focus, and now draw a perpendicular line to this particular line. Now let us consider this point as maybe R. If this is RF, join RF and draw a line perpendicular to RF until it go and meet the directrix. Perpendicular to RF, okay, perpendicular to this until it go and meet the directrix. Okay, this particular line. Perpendicular nothing but 90 degrees. It should go and meet the directrix at any point. Okay. Now this line is perpendicular to this particular, nothing but 90 degrees. Now draw a straight line passing through. The meeting point, let us name this as some T. The point where it got met is T. Now draw a straight line passing through T and R. T, R. Draw a straight line passing through T and R. Something like this. T, S is tangent. Tangent nothing but a line passing through a circumference touching the single point, specific point on the circumference. Okay, so when you draw a line touching the focus, from there draw a 90 degrees line which will touch until it touch the directrix. Let us name this as T, and draw a line passing through TR, an infinite distance line. Now this length is going to be tangent line. TS is tangent. Perpendicular to this particular line, perpendicular to this particular TS is your normal, maybe this line. MN, this MN is normal. This is how we will construct an ellipse by using eccentric method. Okay. To construct this parabola, hyperbola also we will try to implement the same. But here the important thing to be noted is we have to construct everything from the beginning till the end with 2H pencil only. Once this is constructed, this ellipse is constructed, we need to darken that particular ellipse with the help of HB pencil. Only ellipse with HB pencil, followed by tangent and normal also with the HB pencil. This particular TS and MN with HB pencil. This is all for now. This is all about eccentric method, which is the most important method in this particular conic sections. Thank you for now. If you have any queries, you can comment in the box given below. Thank you.